Welcome to the March meeting of the Houston.net Users Group. You're welcome to join us in person for pizza, prizes, and networking on the second Thursday of every month. Our meetings are hosted by Improving Houston in their office at 10111 Richmond Avenue, just inside the Beltway in Houston's West Chase District. You can check us out for meeting notifications at HDNUG.org, on Facebook, or on LinkedIn. Special thanks to this month's sponsor, TEKsystems. TEKsystems recruiters utilize a consultant-first approach to their sourcing efforts. They make sure to ask probing questions regarding what is important to you as it relates to technical skills, career aspirations, and overall interest in types of jobs. This ensures the best match for both the consultant and the customer, leading to a successful engagement for all parties. Let TEKsystems help you find your next opportunity. You can contact them by visiting their website at www.teksystems.com.
Hey guys, how's it going?
Hi.
Tonight we're going to talk about extensibility building, or creating built-in extensibility in software. These are a collection of lessons that I've learned, I guess, over the past 10 years. Most of these lessons came from the work, some work that we did for a Fortune 100 company. It was a 5-year engagement, and they asked us to build some extensible things to sit under their software infrastructure. We built an instrumentation layer, a state layer, and a token service layer. I'll tell you more about those as we go through this. But those ended up sitting under about 400 web services at that organization. Got over, I don't know, somewhere between 1 and 500 million requests a day in that environment. And so it was good. We learned a lot of lessons from that. And then as soon as we finished that engagement, I took all of the lessons that we learned and we built it again. First time we built it, it was owned by them. It was a work for hire. And then the second time, that ended about 2.5, 3 years ago. So we started building again. We haven't finished. It's probably about a 5-year project. So I've got a couple of years left. We've invested a lot of money in it. And what I want to share with you is just some of the lessons that we've learned along the way. And so extensibility, we want to define it. We started a little late tonight, so I'm going to go a little faster and skip a few things. But we want to define it. I want to take a quick trip through history to develop the idea of extensibility. How did we get to the place where we could build extensible software? What is it, and how did we get there? How did we get here? So why do we care about this? Well, extensibility is going to dramatically increase the value and the power of the software we build. Don't always get to build extensible things. It depends on your requirements. But if you have an opportunity to do any kind of investment when you're building software, this topic is about how to think through extensibility and understand and choose what elements of extensibility make sense to build in. And of course, from a developer standpoint, the more value you create in your software, the more you can, boss your manager around, because your manager's always telling you what to do. But if you become really valuable, you just can write your own ticket. You don't have to do anything they say. You get to take home more grocery money, more promotion, more customers if you're looking for customers, and it just increases the security of whatever your situation is. So what is it? What is it as it relates to software in particular? So extensibility is building software that once you've built it, once it's compiled and deployed, some other independent entity can create something that adds to the behavior or the functionality of what you've built. All right? So we can all add new functionality and then rebuild it, right? And we can all configure things to change the behavior. But if you configure something to change the behavior, it's really not extensibility. For instance, let's say we have a config switch in our config file that says logging is on or off. All right? And so you can change behavior by turning logging on or off. But the fact that you've got logging on and off in your system already, that means when you built it and compiled it and deployed it, logging on or off was already one of the features. So what we're talking about is creating the ability for what we build, the consumers of what we build. Who are the consumers of what we build? Well, we might build something that other developers use, so then developers would be our consumers. And we might also build something that users will be consuming. We do that a lot, of course. And so we can build things in a way that users can extend the feature set and the behavior of what we have provided. And that's what we're going to talk about tonight, is how to create extensibility. So, any questions about that? Does that make sense? Cool. Just if you have a question, or just speak up or interrupt, raise your hand, whatever. So here's some categories of extensibility. We'll start with runtime extensibility. So what's a runtime? Well, a runtime is something that's happening on the server. Runtime is you have in-process runtime stuff. That means if you have an app, the stuff that's running in your process, that can be extended. It can be made extensible. You can also have out-of-process extensibility, where something that's running actually outside of your process, but it's connected to your app, so you can extend like that. You can also extend with remote. So we've got in-process, out-of-process, which is kind of on the same box, and then remote, which is on a different box. So those are all extensible things. When you think of pipelines, ASP.NET is the greatest pipeline ever, as far as I'm concerned. That's a very extensible piece of software. So when you build a process that your systems are executing, you can call it a pipeline, and you can build it in an extensible way. When you have certain common things in the way you persist items, like logging, is a common persistence that we do all the time. We're always doing logging or auditing. So we can build our logging and auditing in a way that's very extensible. And then it doesn't matter whether it's synchronous or asynchronous. You can also build extensibility into your runtime using AI. That's getting easier and easier today. Another area of building extensibility in is a data model. So we can build our data model in such a way that customers can extend it. Just to give you an example, think about Salesforce, if you've used that. When you create, or Microsoft Dynamics, any kind of CRM that's a major player, you're going to be able to create an entity in that CRM and be able to create custom fields for it, right? So you can create, a form, and then you can add custom fields to that form, and those will be persisted and be part of your data. And so that's a way that we can build extensibility into our apps. And so if our users need to or would like to, whether they're software developers or whether they're just regular users, if it would benefit them to have custom fields, we can allow them to extend our data model. And we'll talk about how that happens. UI frameworks are also a way to think about extensibility. There are some UI frameworks that are really common, like how many apps do we build that have authentication UI in them? If we're building an app for users, every one of them has a login dialog, every one of them. And if you're letting users log in, then what else do you need to do? Well, you also need to let them reset their password or recover their password. You also need to let them change their profile information and so on. You've got a collection of things. So those are also some elements that we can build that are extensible, that we can build them in an extensible way. Two things that that I'm not going to spend any time on tonight that we can also do that creates extensibility. We're very familiar with the idea of building a web services layer, and so others can consume our apps. So we're not going to talk about that. And that's not really the kind of extensibility that we want to talk about here. And then you can also build extensibility through, it's a new kind of really cool thing in a decentralized way with consensus algorithms. Bitcoin is a really famous technology that uses blockchain that is essentially one flavor of consensus algorithm. So there are others will emerge, and this is something that's new. But we're not going to spend any time on these tonight. We're going to spend most of our time on runtime, and we'll spend a little bit of time on the UI piece. Something to realize, we talk about reuse. Extensibility is the best way to create reuse for your system. Think about ASP.NET. How many ASP.NET applications have been built? Who knows, millions. ASP.NET bits that Microsoft built have been reused millions of times. The reason that they have been reused to that degree is because of the extensibility that was built into that platform. We can create our own pages and plug them in, and they get compiled and linked in. We can create assemblies that get engaged in the runtime in the pipeline. We can create HDB modules, HDB handlers. With MVC, with the new MVC platform, handlers and modules have been deprecated, and we have this new thing called middleware. So the new .NET Core platform has middleware in it. Well, one of the things that Microsoft has always done is they've built extensibility into their runtimes, and then they've used that very extensibility to build the pieces that they ship with it. For example, Microsoft has built the newest ASP.NET platform with a middleware component. So you can create a class that it has some properties you have to comply with the way it works. If you create a middleware class, plug it in with a configuration or programmatically, and your code runs in the middle of the pipeline when a request comes through. Well, guess what? Microsoft built the entire MVC stack as a piece of middleware. So they have a runtime that engages middleware, and so to build the MVC platform and framework, Microsoft took advantage of the middleware architecture, and they built that as a piece of middleware. Same thing when the ASP.NET pipeline used handlers and modules, which there are tons of apps still running today that are using the pipeline that uses modules. The whole page framework was built inside of a handler. So every time that Microsoft has done something in the .NET space, they built extensibility in. And then the things that they built that are most interesting to us, like the ASP.NET page framework with ASPX pages, or the MVC framework that we use now, those are all built as instances of extensible components that we plugged in. So let's go through. So that's what we want to do. So let's go through the past and talk about where it came from. Let's look at what happened through the years of computer science that gave us the ability to extend. And so in the beginning, we started out with machine code. That was the very beginning. Machine code was not extensible. There were no capabilities in machine code for you to plug something in from the outside. When you ran a piece of machine code, everything that it did, you had to code. And if you wanted to change it and make it do something different or something extra, you had to plug it in there and rebuild it and rerun it. So nothing there. When it started out, there was no extensibility. So what came after that? After machine code, we have what? Assembler. ASM comes next. We began to see what could become extensibility with ASM, but we didn't really get there yet. ASM had modules. So you could create a little module like this is a foo module, and it actually just returns 7. That's all it does. So you could create a function or a procedure in assembly language. That was the first place we could do that. And so your code could be running, and then you could jump over to that function and use it, and then it would return back, and then your code would run again. Use stack pointers. That's how it worked. And when you jump to a new piece of code, you'd put another frame on the stack, and it would go through and access your parameters and set up your return value, and then it would jump back and pop that frame off the stack. However, there's still no extensibility. ASM didn't give us any way to extend, it just gave us modular programming. It was the birth of modular programming. That was a very cool abstraction that came along, but it wasn't extensible. So what's next? What's after ASM? I'm going to say C. C was huge. That was the biggest new abstraction. So that happened in 1978. That was the beginning of C. And C gave us the first valuable extensibility mechanism, which today's in .NET's world, you'll see that what .NET has for extensibility at the runtime level is really very similar to this back, 40 years ago when it came out with what was there with C. So what you could do with C is one guy could build some code and another guy could build another DLL. So you had some code over here that's compiled and running or deployed. You had a DLL over here that this guy built. Well, if this guy builds his DLL a certain way, he can plug it in so that that C code is going to engage it. Now, so think about that. The C code that's engaging this new DLL wasn't built with any knowledge of this DLL. This DLL was built later by someone else, unrelated. So this C program has a way of engaging the DLL, and you build a DLL that complies with those rules of engagement, and you get. And so, what is a DLL? A dynamic link library. So why is it called a dynamic link library? Because you can link it in dynamically at runtime, and so somebody can build one, and you can connect it to your code without rebuilding or extending your code. So, what did Bill Gates do with C and DLLs? He built Windows. Microsoft built Windows with DLLs. Think about all the extensibility points that Microsoft enabled with Windows and C. All the drivers, every kind of driver, monitor drivers, printer drivers, every single driver was built with the driver model. And so all these manufacturers, all these other players could create DLLs that Microsoft knew nothing about. All they built was a model, and all these other people built all these other components, and they coupled them together with the code that Microsoft built, and you ended up getting what's certainly arguable as the greatest piece of software that was ever written, the Windows operating system. So I have a question. So what is the greatest piece of software? What do you guys think is the greatest software ever?
Something I wrote.
Something you wrote? I knew somebody would say that.
Well, it's certainly the most successful game changer has been Windows.
Windows has been Windows is going to get a lot of votes there.
Take a look at things that really had the most impact. Yeah, I'm not going to say it's the best, but but it's certainly
Arguably the best.
Where's
Certainly.
Unix fit in?
Unix is another operating system, but
it has more of an impact.
but in today's world there are more servers running Linux than Windows, so it's definitely been a very successful endeavor.
I would also say the most important programming language that made Windows so successful was Visual Basic.
Yeah, Visual Basic extended and we'll talk some more about how why that was so cool. Okay, so who's got another vote for what's the greatest?
Something you haven't mentioned in the history of things is a language called Algol, which ran on the Perl B5000, which was the first stack-oriented machine made in the early 60s. And it,
55.
so,
But Algol was truly multi-task,
Multi-thread machine.
Yeah.
mm,
That's how we used to program equipment systems for that.
And there were a lot of interesting innovations that came along that basically added something to the picture that someone else took and made better along the way. In these slides we're just highlighting a few of them, but man, there's so many of them.
OS was tremendously extensible.
So
Okay, what do you think?
So what about today? What is one of the coolest? What are the coolest OSs today? The hottest OSs around today? I mean, Windows is still ubiquitous on the desktop, and I think there's 85% market share still with Microsoft with Windows on the desktop. So it's dominating the competition on the desktop. But in other areas, what else is really cool?
Unix is dominating the phones.
Android is beating iOS on the phones. Android's a flavor of Unix. Android's got about Android's got about 50-something percent market share, and Apple is in the 40s. So you've got that. So
Linux has a very strong presence in its systems. The Raspberry Pi 3, for example, was Linux variant available for it.
So let's just think about that. Let's think about Android, which is a cousin of Unix and Linux. Let's think about Android and Apple on the phones. What makes them so amazingly useful? Why are our phones so useful today? Because we've got all these apps.
They're not phones.
That's right. They're our little desktops.
But
Yeah.
you can talk about extensibility, I'm not sure kind of where this fits in, but I'm gonna have to say, kind of go back to VisiCalc. I remember when the Apple IIs, first came out, and every manager had to have VisiCalc, on the machine. That was a game changer for how we did computing and how we did the demand for computing.
And so I have a question for you. That's good. I have a question. Isn't the ability for an operating system to run an app, in a sense, of a measure of extensibility? I mean, if we have a phone that Apple built this is an Android and this is an iOS, if we had a phone that one of these two manufacturers built, or OS vendors built all the apps for, it wouldn't have very many apps. It wouldn't be that useful. And besides, their apps are not any good anyway for the most part.
Which is why I mentioned Visual Basic. Visual
Yeah.
Basic a while back, because it allowed people who were very technical but not programmers necessarily to be very, very productive.
Well, that's all operating systems basically do that.
Yeah.
Nobody did it like VB.
But I mean, every time you added a program to it, you extended
Right.
the functionality of that computer.
The great software of the world has always been software that has enabled extensibility and embraced it and allowed amazing extensibility to take place with its consumers. So let's remember that, because when we're building software, we can do that too. We're not going to invest as much as those OS vendors did, but we can build standout software by including extensibility. So what's next after C?
You talking about the interpretive languages? Or?
Well, I'm going to say it's C++. C++ had a very interesting mechanism that was introduced that enabled, in a big way, what we see today in .NET as the major mechanism for extensibility. And what is that? C++ brought us really polymorphism. So what's polymorphism? I have a class called shape, and it has a method called area. And then I take that class and I create a rectangle class, and it derives from shape. So it inherits the implementation of shape. Shape has one member, the virtual member int, which means rectangle can replace shape's int with area with its own int area. So with the rectangle, we're going to create our int area function and return width times height, which is the function of area for rectangle. We're going to do the same with triangle. We're going to do 1/2 times width times height. And so because of that, we can write code, because of polymorphism and runtime binding, late binding that happens at runtime with these elements, we can take a shape pointer in C++ and create a rectangle and a triangle, and we can assign that rectangle to the shape pointer, and we can assign that triangle to the shape pointer, and we can call the area method, and we can get the area method out of the rectangle class for the shape pointer that's assigned to the rectangle, and we get the area method out of the triangle class for the pointer that's assigned to the triangle. So this technique right here evolves a little bit with the idea of interfaces. So this is called implementation inheritance-based polymorphism. And then one more thing that happened after this is with C++, we had the idea of an abstract class where you had a class definition, but the methods didn't have any implementation. In other words, you said, hey, here's a method, but I'm not even going to put a default implementation in there. And so with C++, we have abstract classes. With for instance, with .NET languages, we have interfaces, which are essentially abstract classes. And so when you inherit, you can build a component that inherits from a base class, that means it has some functionality in it that you can take advantage of. But if you inherit from an interface, there's no functionality and you build it all out. But both of those are core to the ability to extend with .NET applications. So what's next after C++? There was a new innovation that brought a new quality to the ability to extend.
Dynamic languages?
Not quite yet. Let's don't go to dynamic languages yet. Let's go to something that happened in 1993 at Microsoft. Now, it isn't Visual Basic because that was 1991. What did Microsoft create and start using in 1993?
COM.
It was COM. It was COM. In my interview at Microsoft, which happened in 1997, there was a guy there. He walked in. I had to wear a suit. He walked in blue jeans and literally a white T-shirt, kind of like right off the farm, tennis shoes. And he sat down and gave me a marker, and I had a little whiteboard, and he said, "Tell me everything you know about COM." And that was the interview question for him. That's all he wanted to know. COM shipped in 1993. What did COM bring to extensibility that hadn't really been there before? That was very interesting. That .NET expounded on and made in a much more significant way. What did COM bring to the picture? COM allowed you to build with one language and extend with another language. When Visual Basic shipped, I think it was version 4, version 5, COM was part of VB, so you could build something in C++ as a COM component, VB4, COM was part of VB4. You could build something in C++ as a COM component, and in Visual Basic you could consume it, right?
VBX is in COM 3. I mean, VBX is in VB3, or a hint of what was to come.
The people that were creating Visual Basic at Microsoft were well aware of what was going on in the COM space. And so when Microsoft shipped COM, and most of what we're talking about is on the Microsoft stack. There are other analogous concepts on other stacks. We're talking about Microsoft stack. When Microsoft shipped COM, now we could build in multiple languages. I could build something in one language that didn't even know about something that someone was building in another language, and then at runtime I could configure those two things to work together, and I could engage that other thing and extend or change the behavior of my application. So that was the cool thing that happened with COM. Yep.
I've always wanted, what's this? Is ActiveX really COM?
ActiveX is COM. ActiveX components are COM components.
Not different.
But not all COM components are ActiveX components.
So
Right.
what says I got an ActiveX first?
iDispatch.
What?
You have to implement iDispatch.
Dispatch?
iDispatch. So the core COM interface is IUnknown,
Yep.
and ActiveX is a subset of COM in that you have to implement IUnknown because iDispatch inherits from IUnknown. And the difference between a straight pure COM component and an ActiveX component is simply the implementation of iDispatch, which is the interface that allows for late biking.
I just knew Jay Sawyer was going to answer that question.
No, that's cool.
He did a very good job. So,
And that is how useful these days?
not very.
In
Question?
ActiveX, do we have another difference that ActiveX can also have the UI component?
COM can also have a
built in?
UI.
COM can also have it?
But there became somewhat of an alignment between ActiveX and UI-driven components. And COM components sort of went down the path of being server non-UI components. That's just what people did. That's the way they did. You didn't have to do it that way, but it just began to, because there was some affinity there that made sense. Okay, so who was the king of COM in the 90s? It's a man. I'm thinking of a man. It has to be Don Box. It totally has to be Don Box. And when Don Box being the king of COM, being the chief scientist or technologist at the Developmentor organization. Developmentor was a training company that made its business teaching developers COM. COM was somewhat complicated. And at Microsoft, I'll tell you one thing about Developmentor that's interesting. Developmentor would have classes. You'd pay $4,000 a week to go to their classes. That would cover your hotel and some food, all right? And they would put 100 people in a room and get 2 instructors to deliver that class. Think about the revenue model. Developmentor makes $400,000 that week. They pay 2 guys a week's pay, and all they have to do is pay a hotel room for everybody out of that. They had great hotel discounts. They were just raking in the money. And because of that, Don Box had a decision to make when he got up every morning, and his decision was, which Porsche am I going to drive to work today?
How do you spell his last name?
BOX. He's a distinguished engineer at Microsoft right now, I believe. Well, so one of the...
It still has an Army portion.
yes, probably still has it. One of the goals that Microsoft had with the next innovation, which is sort of by accident, was to take the complexity of COM and make a better COM that was much simpler. So what's next? What happened next? This one happened in 2000. What did Microsoft ship in 2000? .NET. Microsoft shipped .NET in 2000. Microsoft shipped .NET. They were building Java. In fact, well, I think Bill announced it in 2000.
Announced it in 2000.
Yes, he did. So, and you were, let's see, you and I were working at Microsoft then, right?
I was in Redmond for MS 101 when they did the announcement.
Yeah. You were, that was when you met me at the dev thing. That was, yeah. Jay was a regional director at the time, and one of his speakers at Dev Days was having a baby, and somebody called.
99.
Yeah, somebody called me and said, "Hey, you need to go do a COM Plus talk at Dev Days because the speaker is having a baby," and that's when we met. We had a meal somewhere, and he asked for lemons. I'll never forget the big pile of lemons that he gave. So it's if you invite him over for tea for dinner and you're going to have tea, make sure you have like a big bowl of lemons there for him. That's what you need. So .NET shipped. .NET, the fact that .NET came to be was interesting because Microsoft had, in the middle of the 90s, Microsoft had essentially given up on C++ and VB as programming languages that were going to dominate the next decade or two. And they had decided that Java was going to be it, and they were going to build the best Java engine out there. You know what they did that really pissed Sun Microsystems off? They put COM in the Microsoft Java machine. When they did that, Scott McNeely at Sun Microsystems, the owner of Java at the time, decided to sue Microsoft for that. And as a result, Microsoft decided to take all their Java technology and morph it into a different kind of runtime that would compete with Java, and that became the CLR. So if Scott McNeely had not sued Bill, then we'd all be writing Java code today. But he did, and the rest is history. And so with .NET, we enter the things present, because that's where we are right now. So things past leading up to extensibility. So now we've got .NET, it's a better COM. Instead of COM components where we write assemblies, assemblies are, you don't have to have object-oriented languages to build assemblies, but we're going to use those as our concept tonight. We're going to be talking about C#. And with C#, you have implementation-based inheritance and polymorphism, and you also can have interface-based inheritance with polymorphism. And using one of those two is your fundamental technique for creating extensibility. So how do we create extensibility in .NET? What do we do to create a program that can dynamically engage an assembly that someone else wrote. How do we do that in a way that where when we build software, we can, let's call it a provider model. We can build a provider model in our software, and if you want to extend the application that we build, someone can create a provider for it that does something different, that has a functionality as a provider that we didn't think of or that wasn't built into our code. So the first thing you do is you create an interface. This is how we do it. So you don't exactly have to do it this way, but these are all of the concepts. Somehow you're going to create something similar to this if you do it in a different way. The concepts are still going to be there. So you can create an interface, and then for ease of use and to organize the providers, we build a wrapper class, a wrapper abstraction. We define the required configuration elements for the providers that are going to implement the interface. And then we create our code that uses the providers, whatever it is. We'll talk about some examples of that in just a second. We create something or leverage something that loads the providers dynamically. Then we create the providers. We create a couple ourselves to ship with our product, and then we invite everyone else to build their own providers. We allow the providers to have configuration, so we create custom configuration section for that, and we define those providers in that configuration file using that configuration syntax. And then what we have is a manager layer that can engage providers. So then what we do is we talk to the manager layer in our code. So what we do in our code is we talk to the manager layer. We don't know what providers are going to be out there, but we just talk to the manager layer. And when we talk to the manager layer, it engages whatever providers are there. So let's think about an example. Let's say we're going to build a piece of code that does authentication, but we want to allow different authentication stores to play. So sometimes we may want to authenticate against ASP.NET Identity. Sometimes we may want to authenticate against Active Directory. Sometimes we may want to authenticate against an IBM 3090. Sometimes we may want to authenticate against Oracle Access Manager. So you got like 4 different mechanisms there for authentication. So if we build a manager class for authentication, it's going to have a method in it called validate credentials. That would be a reasonable one to have. So our interface for providers would have, say, a validate method in it. So somebody could build a provider for ASP.NET Identity. Somebody could build one for the 3090. We're going to ship the one for AD, and somebody else builds one for Oracle Access Manager. Then somebody else does some custom authentication store, and they build a provider for that. Well, so when our app runs and we get user credentials and we authenticate, then it's going to use the provider that's configured with the app. So depending on which provider it is, it's going to go to IBM or Oracle Access Manager or wherever based on what's in the configuration. But our code doesn't have to change. We've built our code, we've shipped it, it uses the manager class, and the consumers of our code can put their own provider on it and engage whatever authentication store they want. Here's some other examples. Authentication we just talked about. Claims acquisition. Where are you going to get your claims when you authorize? Everybody's got a different place to store authorization metadata, right? Then what kind of token are you going to do with authentication? One person wants to do a SAML token, another person wants to do an OAuth token, another person wants to do some other kind of token, right? So if we built a token service that could authenticate and get claims and issue a token, then it would be meaningful and extensible if we created a provider model for the authentication piece, provider model for the claims acquisition piece, and a provider model for the token generation piece. That way, if I got that token service and used it, I could authenticate against whatever I wanted to. I could get claims from wherever I wanted to, whatever claims I wanted to get, and I could create whatever kind of token that I wanted to use. It would be simple. I would just configure or create the providers that made sense. What about state management? When we create state management technology where we're handling state behind a big web app, we could do SQL Server state, we could do file-based state. Wherever we wanted to put that state for persistence is our choice. So if you build a state management solution that uses providers, it's going to be much better than if you build a state management solution that's bound to some single persistence layer. It's not going to be as powerful or as valuable. Caching. What about caching? What if we had a provider-driven cache technology where you could actually have multiple cache layers? So let's say one cache layer, the top cache layer was memory cache, all right? So if I have a cache manager and I ask the cache manager, go get me the value of this key. So that's what my code does. Well, the cache manager behind the scenes has 3 providers. Let's say it's got 3 providers. And then let's say underneath that, it's even got a data provider. So what could those providers be? So one of them could be a memory provider. I've got my cache data in memory on web server. So I got 5 web servers in my farm, and each web server has a different set of items in memory based on what the users are doing. So I've got a memory cache provider. Then what if the data is not found in the memory cache provider? What could it do? Are we just screwed? No. Underneath that, we could put a distributed cache provider. So if the memory cache provider doesn't have it, it goes and talks to the distributed cache provider. What if the distributed cache provider doesn't have it? Well, we could have it in the database. You know, that's better than not having it at all, right? And what if we look in the database and we don't find it? Then we could even code a data provider that would know how to go get that thing. Like let's say we're an automotive company and we want the qualities of a particular car that we're shipping. So some user makes a request that says, hey, I want to know some stuff about the Ford F-150, the 2018 model. And that request comes into the website. So on that web server, the code looks for, hey, what's going on with the F-150 for 2018? It's not in memory. So then it looks down in the distributed cache. Well, this is the first request of the day, so it's not in the distributed cache either. Looks in the database, nothing in the database. First request of the day, we cleared out cache in the middle of the night. So then our data provider can say, hey, I know how to go get the stuff for the F-150 2018. So it goes and gets it, puts it in the database, puts it in the distributed cache, puts it in memory, and loads it back to the user. So then we have an auto-populating cache, technology that has different layers. If we're running out of memory on the web server, IIS is going to dump some of the stuff out of the cache, or we're going to make it work where it dumps stuff out of the cache. But if it's not in the memory, we still got it in the distributed cache. If it's not in there, it can be in the database. And so create a really cool caching solution like that. So all these things are ways that if you build provider models into your technology, in your applications, they're going to be really cool. So I want to look at a couple of things now that we talked about. So I want to look at that states. I want to just show you a simple state service that does these things that we talked about. So at the very beginning with the items that we said we needed, you need an interface. So this is our state interface. You could use the same kind of interface for caching. What do we need in our state interface? We need a get item, an add item, and maybe a remove item. And a state bag in this scenario is a collection of items. So a state bag has an ID, and each bag has a key value pairs in it. So let's say Joe has a token, and the token ID is a GUID, or let's say it's an int and it's 100, okay? So if I want to get Joe's state, I would go and get item 100. When I got item 100, it doesn't just have one value in it, it has a key value collection in there. So item 100 has a bag, and the bag has a collection. So that's basically the architecture of this state interface right here. So here's our interface, all right? So now what do we want to do? We want to create a manager, some kind of wrapper class that our code can engage. So obviously if we create a wrapper class, we're going to have static members. That's the way these are created. We're going to have static members that are add item. We're going to have a get item static member. So things that map to the interface methods, we're going to put in our manager class. So in this manager class, let's see. Here's what we've got here. We've got essentially what you see here is the items, the method names that are aligned with what was in the interface. And then also I want to show you something that happens in the static constructor. In the static constructor, we actually go and create an instance of our provider. So when this application fires up, the static constructor is going to execute early in this application's instance lifetime. And the static constructor is going to get our provider. So we're going to, and then it's going to get the provider configuration right here, and it's going to create an instance of the provider, and that provider is going to be used underneath all these methods, because when I want to get an item right here, we're going to take the provider instance and we're going to call the get item method on the provider, which is on the interface. And I don't know where this, see when we code this manager class right here, we have no idea where this get item is going to come from. We don't know if it's going to come from memory, or whether it's going to come from a distributed cache, or whether it's going to come from, I'm sorry, we don't know whether it's going to come from memory or whether it's going to come from a database, let's say. So what's going to determine where it comes from is our provider. So let's go think about what we want to have for a provider. So see, where is the provider? Here. Here's one right here. This provider is a SQL Server provider, so it's going to be using state in SQL Server. So we're going to be deriving from our interface, this interface right here that we're going to be using that the state manager is going to be using. We're also going to be deriving from another interface, this one right here, and I'll show you what that one does in just a second. So SQL Server has how do you add a state bag to SQL Server? Well, here's the ADO.NET code that does that. And then how do you add an item to state? Well, that means you're adding an item to a bag. If you add a bag, you're adding a collection of items. If you're adding an item, you're adding one thing to the bag. So here's the SQL Server code that adds an item. Let's see. We're going to, if there's no bag, we're going to add the bag, and if there is a bag, we're going to add the item to the bag. How do we get a bag? Well, here's the SQL Server code that gets a whole bag of state. That's a user's collection of key value pairs that make up their state, and so on. So the SQL Server provider is going to do all the things with SQL Server to get that state out. Now, how do we engage this provider? Well, so we're going to have to set up a configuration file, and in our configuration file, we're going to need some kind of way of describing the provider. So in this case, this is a provider configuration that's very database centric. If we wanted to save state somewhere beside a database, besides a database, we wouldn't have a connection string in here. But in this case, we're going to have a name, a type, and a connection string. The name gives it a friendly name. The type defines the .NET type that it defines my provider type in .NET type semantics, which we'll see in just a second. And the connection string is going to be what we come to know and love as a SQL Server connection string. So when we define our provider in the config file, it's going to look like this. Here's the name. Here's the type. Here's our namespace.class. Here's our assembly name, right? Type equals namespace.class, comma, assembly information. And then we have our connection string here. So in our configuration file, we have an element called state settings, and it's just a collection of state providers. So that's exactly what you see here. we have a state settings element, which is a collection of providers, and each provider is a state provider configuration element. Then we've defined a custom config section here, and here's our config handler. And so in our state manager, we're going to get our configuration. We're going to get the first provider that's in the collection, and then we're going to create an instance of that provider. And we have a class called a type manager that does that, and all the type manager does is it goes and it parses this type string right here. This guy parses that, all right? And then after it parses that, it knows what the assembly is. It's going to be this part right here. And so it's going to load the assembly. And then once it's loaded the assembly, it's going to create an instance of that. And so how is it going to create an instance? Well, see this create type instance right here? Let's go see what that does. Create a type instance. It's going to take that type def. It's going to break it up into parts. It's going to load the assembly. Once it gets a reference to the assembly, it's going to create an instance of the class, the namespace.class aspect of that type string. And if it gets an instance out, then it's also going to do, it's going to look for all of the expected interfaces that are in that type, and then it's going to return it. And so what we've got in our state manager class is we've got the code in the type, we're leveraging the type manager class in the state manager, and it's going to go and create an instance of our provider. Once we've got the provider, we're going to cast it with the interface, and here it is. So every call to the state manager class is going to leverage that provider. Sometimes you want to have multiple providers in a class, like for instance, when you have, let's take logging, for example. Why would you want to have multiple logging providers at the same time? What's a scenario? Different organizations, is that what you said? Someone else?
Different venues, email versus text versus database.
You might want to do different kinds of logging. So here's an example. Let's say I want to log most things, everything to SQL Server. So I have one provider that's all SQL Server. And when I'm logging an event, you know, I'm going to not just pass in a string. It's going to, let's say we have an event ID. Oh, this is a so-and-so kind of event, and here's your information about it. Well, some events might also be of interest to the auditor. Maybe we have some kind of compliance that we have to deal with, and this event is an audit event. So I'm going to have a SQL Server provider, and I'm going to have an audit provider. So when I fire an instrumentation event, I'm going to put it in SQL Server every time. Then sometimes, if it's the right kind of event, the audit provider is going to save it to wherever it needs to save it for auditing. A lot of times the audit provider might ignore the event. Like an audit provider wouldn't care if the event said, hey, the user clicked a button. Nobody cares about that from a compliance standpoint. But if someone logged in, that's the kind of event that an auditor or compliance, you know, somebody would care about from that standpoint. So the audit provider is going to have some intelligence, or the instrumentation layer is going to do it for the providers to say, hey, these are the events that I do, and these are the events that the SQL Server provider does. And then there's another provider that we've used. Let me just show you this one. It is a, where is it? Here it is. PagerDuty instrumentation provider. Who knows what PagerDuty is? It's a SaaS app out there on the web. So did you know, Josh? PagerDuty is an, I can pull up my PagerDuty app on my phone here. So if an event comes across instrumentation that is a critical application event, like an outage, or something that needs attention from an operations person, like immediately, then the PagerDuty provider takes keen interest in those events, and it sends them off through a web service call to the PagerDuty service that costs like $30 a month for an account. And you go in your PagerDuty service, you configure the people that are going to get these events. Like you might say, send it to Stephen F. first, and if he doesn't answer, then send it to Jay Sawyer. And if he doesn't answer, then send it to some other places. So you set up some escalation there, and Jay Sawyer wants to get it before Stephen F. does because he wants credit to fix it. So
I don't want any parts of it. I want none of it.
So the instrumentation layer can even invoke application monitoring events so that the DBA that needs to go look at that database is sitting at lunch and your app's running and an instrumentation event fires and he gets pinged and he has to get up from his lunch and go back to the office because one of the databases is running into some critical issues and the connections are not happening every time, or the connections are taking too long. Instead of a less than 5-second connection time, it's taking 22 seconds to get a connection. Well, that means the database is not healthy. So somebody needs to go look at that right away or you're going to be down soon. And so sometimes you want to have a multi-provider architecture scenario. So these are instances of the provider model. That's one kind of extensibility that you can build into your apps. And if you build enough layers with enough extensibility in there, then when you lay down a new app, you've just about got your whole infrastructure done. You've got your authentication done, you've got your authorization done, you've got your instrumentation, you've got your state management, your caching, et cetera. You've got just about your whole operations layer for your apps done. And that's a pretty amazing and valuable thing to have. Any questions about that before we go into the next topic? Yeah.
Did I see a part in there when you were scrolling around? It seemed like there was some kind of validation to ensure that the loaded assembly was providing the appropriate interface.
Yeah. So that's a good point. So just because I load an assembly and create an instance of a state provider doesn't mean that the guy that wrote that state provider actually implemented the right interface, right? I can load a class and I can load an assembly and get an instance of a class and say this is going to be my state provider interface, and then when I try to cast it to the this is going to be my state provider, and I try to cast it to the interface, guess what's going to happen? Runtime error. So then state's going to be down if I don't trap that and deal with it. So obviously while you're loading up these providers and getting everything ready, one of the things you're going to want to do is instrument heavily. Because if your app starts up and your state provider is down, you are dead. Somebody better get up from lunch and go fix that, So that's just one of those things that needs to be instrumented and sent off to PagerDuty. If your server fires up and one of your providers does not load, somebody needs to be disrupted right away. And if they're not, then what's going to happen is you got one web server in your farm that's not going to be healthy, and customers and users are going to be getting exceptions there and errors, and you're going to end up hearing about it one way or another. It's going to affect you because the quality of your stuff sucks, and then you're not going to get as much grocery money at the end of the year for your Christmas bonus. So, got to take care of your instrumentation. All right, so data model extensibility. This is something that you ship an app with entities. You've got let's say user entity, that's a good example. How many of us define users with similar properties? All of us. Okay, but we also have some special properties for different applications that need to define a user. One app needs to know the user's hair color because of something that it does. Another app needs to know the kind of car the user has. Another app needs to know the user's address because it has something to do with the physical geography. And then my app is just a SaaS app, and I don't care anything, but I just need to know the user's email address, and they need to have a good password. And that's all I care about. So we have different kinds of data that we want for users. So in your app, if you want to make that extensible, you ship the core user property set, and then you give developers the ability to add attributes to the user. That's what you do. And you do that through data model extensibility. When you give them the ability to add attributes, you also want to give them the ability to set default settings on those attributes, perhaps. You might also want to give them the ability to validate those attributes. Like when they put in an address, you want to make sure that address is valid. Or when they put in the kind of car they have, you want to make sure that that really is a car that's getting shipped out there today or that's existing out there today. You also might have some dependencies. You might ask the user, you might have some questions about the user where if they answer it one way, they get this set of questions. If they answer it another way, they get this set. So think about every time you go to the doctor's office, and we need to go ahead and just launch right into identity politics right here and say you get a question at the doctor's office that says male or female. If you get a female, if you check the female, you're going to have another set of questions over here that have nothing to do with me, for example, because I'm not going to answer those. I'm going to get some other ones that are totally associated with being a male. So therefore, sometimes you want attribute dependency and requirements based on what another attribute's value is. Does that make sense? And so how do you do that? How do you do all of this? Well, so on the database side, you have your user table and it has your columns. Let's say you decide that the user columns that everybody needs are a user name and an email address. And the name could be an email address or it could be different. But no matter what situation this authentication is going to happen in, everybody's going to need a username and an email address, all right? And of course, you'll have a credential stored as a hash probably. And you're also going to have some user management things like when's their last login and is the account locked out and did they register but they're not activated, or did they register and they are activated so now they can log in. You're going to have some things like that. But you're not going to have their address there, and you're not going to have the car type and all that. You're going to let somebody add those. So how are they going to add them? So the way they're going to add them is you're going to build a table, and let's just do that. So in this extensibility database, I'm going to create a new table called an attribute table. We're going to make it look something similar to this. You're going to have an attribute ID. Let's just say it's an int, all right? And guess what? You're going to have this is going to be the user attribute table, so let's just call it user attribute. And then you're also going to have a user ID in here, right? You got to connect this attribute to the user, correct? And then you're going to have a value. Now you could, sorry, this user ID is not going to be a varchar. So let's make it look like that. This value, let's say this value is going to be 50 characters. That's all we're going to give it. That's not realistic, but let's just say we're going to do that. Now, let's say what you're asking for is a date. So you could make everything a string. You could say, hey, I'm just going to serialize everything to a string, and that's the way it's going to be. The date's going to be a string form of the date. The car is going to be a string form of the car, and so on. Or you could go down another path, and I've seen it done both ways very well. You could call this an int value. And then you could call this one up here a string value. And so you could build in columns in your attribute table, so depending on what that attribute's value type was, that's the column that you would put it in. So if this was an user attribute that described the user's age, then you might put it here. If it was an attribute that described the type of car they have, well, you might put that here. So I've seen it done very well this way, which is simple, and this way, which is more complex. Sometimes the complexity of the scenario makes it easy to make that decision, and sometimes it just depends on whether the developer's a perfectionist or not. If they're a perfectionist, they're going to fill out all those types. So that's where you would put your values. Now, where would you put your attribute definitions? So this is an attribute ID. We forgot one over here. It's not only the user, we not only have to have the user ID, but we have to have the attribute ID. And let's call that an int. So which user does this attribute go to? Which attribute is it, and what's the value? So now our attribute table is going to look like this, and we're going to have attribute name. And after we set up the name, we're going to have a data type. Let's say we have a table of data types, so we're going to have an ID. What does a data type mean? Well, is it an int? Is it a string? Is it a double? Is it an address type? What kind of type is it? And then, oh, by the way, we're going to have to display this on the screen in a form presentation for somebody to type in the value. So we've got to say, what's the control that we're going to use to display this value? For instance, if it's a date, we might use a date picker, all right? If it's a string, we might use a text box. If it's a bool, we might use a radio button, all right? So we're going to have a table that defines the name of the attribute, the type of the attribute, what control we're going to use to display it, and then here's something that I want to show you that's interesting. We're going to finish up talking about this. By the way, what's our time limit?
About 15 more minutes.
All right, 15 more minutes.
20.
Okay. We could go for a couple more hours.
Depends on how long our improving host wants to stay.
Okay. All right, so
Start walking out, it's time to wrap up.
yeah, you guys just go ahead and give me that signal when it's time to wrap. So now we want to, remember we talked about on the slide deck, we talked about some things like default setting, validation, we talked about requirements and dependencies. How are we going to let people define that stuff without writing any code to represent the logic? I mean, how's that going to work? Well, one of the coolest ways to do it is a UDE, a user-defined expression. Let's get a default UDE. Well, let's do it that way. And let's say this UDE is going to be an expression, so we're going to represent it as a string, all right? And let's say we're going to let them put in a pretty decent sized UDE for the default. In other words, when they define the default for this attribute, we're going to let them put in an expression that's 256 characters. All right? Well, more than the default, how are we going to validate this thing? So the default is one aspect. We also need to, after they type in the value that they want, make sure that that's okay. Okay? So we have a validation user-defined expression. That's also going to be 256, all right? There's more. We also may want to define some other attribute that this one depends on. So we might add some other UDEs and identifiers that say, hey, you know what? If this other attribute is less than 100, then this attribute is required. Otherwise, it's optional, all right? And so you can code out some logic like that. If you've used any of the Dynamics or the Salesforce technology that does this, you'll run into a wall right here because they'll give you like a list, but they won't give you conditional dependencies. So let's totally show them up and code in some conditional dependencies. So you can build in a set of UDEs and a set of other properties for your attribute that will allow you to support conditional dependencies as well. So right now we've got two UDEs. Let's stop with that. So So let's think about what we've got. We've got a way to persist the value of the user. So we've got our user database, and we've got our typical authentication stuff there, but now we've got extensions to that typical authentication stuff that's defined by these attributes. So now, if somebody comes along and configures some extra attributes, then not only will our database support it, but our UI is going to support it as well. How's the UI going to support it? Well, we're going to have code that looks at the attribute set and dynamically expresses the UI. So how's that going to happen? Well, let's take like a web app. Here's an example right here. Let's say if the attribute, let's just change this up a little bit. This code is a little piece of code that comes out of a production app. But let's say if some string, let's say we're going through a loop of all our attributes, all right? And we're in the middle of a CHTML file right here. So we're in MVC, we're setting up our view that's going to be sent out, and we want to check to see if the string, let's just say this right here. I'm going to put a little comment here. String holds the control type for the attribute. All right. So if this one is radio button, let's just say the control type ends up being radio button for that one, then we're going to drop a radio button in the user interface right here. Okay? So we not only have to drop the right controls in to get the values, but then when they click the save button, we have to connect up with these things that we stuck in there, and we have to say, oh, this is attribute ID 25, and the user that's actually editing their profile right now is Joe, and so I'm going to go put a row in the table for Joe that we created. Here's our table right here, and we got user ID, that's going to be Joe. I'm putting a new row in here. User ID is Joe, attribute ID is 25, and the attribute string is going to be, remember that was a radio button, so the attribute string is going to be true. So Joe's just saved a true that, let's say we ask a question, do you drive a motorcycle? Do you ride a motorcycle? Because we're on a car insurance app. So let's make it Jay. Jay's the user. Does Jay ride a motorcycle? He's going to answer yes there, so it's going to be true. All right? So we're going to have a whole table of values that are connected to users and those extra attributes that we define. So we define the attributes here, all our attributes for users, we defined them here. The values that people have coded into those attributes as they've used our product are coded into this table. And so whenever we want to see what a user's answer is for the motorcycle question, we're going to look for that user ID plus attribute ID 25, and we get back a true or false. So that's how we're going to build our UI. Now, what are we going to do about these user-defined expression things? Well, so one of the things that we did is we came across an expression parser that we thought we liked it. It's a shareware thing, and if you want to know what it is, I don't know what it is right at this very minute, but we built some code around it. I'm going to show you some of it. Where is it? Here it is. Yeah, this is it. All right. So this is a solution that we have. This is our UDE framework that we did. And this is the real deal, the one that we use. So how does it work? Well, a user-defined expression, let's just load up this test tool and look at a couple of things. User-defined expressions are expressions. They're single-line entities of code, all right? You could build a user-defined expression engine around dynamically processing C#, where you could use the emitting reflection technology built into the CLR to actually compile that stuff and execute it. And in that case, you're not limited to a single line. People could actually put a blob of code in there that had functions and all kinds of stuff in there, all right? You just need to define a way to start that code up, and the rest of it would just run. So these are expressions, are they not? Check out these expressions. A minus B plus 35, that's an expression. something contains, or SL, string SL contains capital Z, that's an expression, you know? So when you code a default, so these expressions return different types. Max A and B returns whatever A and B is. If A and B is a string, then max A and B is going to return a string. If A and B are ints, and then max A and B is going to return an int. M equals test, that sounds like a Boolean expression, so we're going to get true or false out of that, right? And then you've got this array up here. You know, when you just declare an array, then that's going to return an array, right? Duration is less than n minus start. That sounds like dates. You're comparing one date to another and getting a Boolean out, you know? So your expression engine can process a collection of base types with a collection of supported functions. So how does it work? So if I've got an expression engine that's going to analyze one of those expressions, it's going to parse it, right? So it's going to parse it into literals, and it's going to parse it into symbols, and it's going to parse it into functions, and it's going to have operators. So when it deals with the literals and the operators, that's going to be easy. But when it comes to a symbol like A or B, or it comes to a function like contains, the expression engine itself isn't going to know how to do the contains thing. And so it's going to basically ask for some help. Let's say it asks for help from a function resolver. There's a function resolver that knows how to do contains, all right? And there's a symbol resolver that knows how to go get A and B, all right? And that's exactly the way this one works. You have function resolvers and symbol resolvers, and the function resolvers, when the expression engine says, hey, I've got a function here, and it's got these parameters, I need somebody to tell me what this is, so it's going to pass that over to the function resolver and say, hey, function resolver, give me a value for this. So ultimately, you're going to get down to one value, and that's what your expression is. So your default for, let's say, the default for your automobile type, let's say we decide there's going to be a default for that because this is a Honda app, and it's going to be Honda. We expect it to be Honda, but you might put Acura in there, okay? So default is going to be Honda. So the expression that I'm going to type in the database for this guy right here is going to be quote Honda close quote, all right? That's just a simple expression. Now I could do a really fantastical default where I call a bunch of functions and had a bunch of other logic on there, and it was just this amazing thing, okay? And I could also do something similar to validation. So let's think about this. So this expression engine, it could, so if I actually go back to that and just hit this evaluate, it's going to evaluate all those guys, and it evaluates them by breaking them out. Guess what? This guy has two symbols, A and B. This one has an NL symbol. This one has start and end. These are all symbols. They're not functions, they're symbols. And I have to have a symbol resolver to tell me what is start. Well, start's kind of defined over here. But when you build a rich expression engine, start could be anything that has to do with your app. Start could actually drill into SQL Server and get a value out, right? So it's just a matter of what you code into your symbol resolver and your function resolver. If you write a function resolver, for instance, we're building an app right now for the medical space. I don't know if you've heard of DICOM images, but DICOM is the medical standard for images. And when you have a JPEG, you just got a picture. When you have a JPEG as a DICOM image, you can have 3,722 attributes with that JPEG in the same file. And these attributes are all kinds of things. You know, what's the patient, and you know, what kind of picture is this? Is this an MR picture from an MRI, or is this an X-ray, or what is it? 3,722 things. Man, you know, it took a long time to sit around the coffee table and figure all those out. Just think about all the arguments they had. So you can, to get a value out of an image, you're actually running your stuff on the web server. You're going to check the database, find out where the image is, go hit the hard drive, open up that image, parse that DICOM header, and get the fact that the slice depth for this MRI on this machine is 5 millimeters. So you're going to get a 5 out of it. And so when you're building these attributes, if you have user-defined expressions to govern certain things about the attributes, then you can do whatever you want. All you have to do is just code it into your symbol resolver or your function resolver, right? So how does that work? You know, guess what? You're going to see a really similar pattern here. So let's look at our app config and see what the function resolvers and the symbol resolvers look like. Well, in this particular extensibility model that we did for this, we've got UDE settings, user-defined expression settings. We're enabling it. A lot of times we'll throw in the enable flag in different places where it makes sense. Now, first of all, we have to have an engine that's going to evaluate the expression. You don't have to use the same one all the time. Remember, all you have to abstract an engine is another provider. So this engine that did those expressions is one type of engine, and it's sitting right in here in this namespace and class and in this assembly right here. Guess what? It has function resolvers. By the way, this init thing is something that it might need to configure itself when you start up. Like if you're hitting a database, what do you need when you're starting up to configure yourself? You need a connection string. Well, if you're a sockets thing, then you're going to need a port, you know, and an IP address to connect yourself to, and so on. So everything might need some, and we usually use a simple initialization string. You could pack multiple things in here by, you know, delimiting it with semicolons or something. Or if you need to, you can make this more complex and make this a complex XML element that has a richer type structure on it. But anyway, that's what we're using for configuration. And then you have a set of function resolvers. We only have one here, and this is the function resolver, namespace.class, and then here's the assembly that's in, so on. And so when this thing fires up, it doesn't know what expression engine it's using. It doesn't know what the function resolvers are, and it doesn't know what the symbol resolvers are. It's going to figure all that out with this configuration. It's going to load them up, and it's going to engage them through that interface that we use to define the providers. And so here's a thing that allows you to extend your apps, user-defined expressions, and it's built in an extensible way. So you can extend it as well if you want to. So let's paint a big picture here with one more thing, and then we're done. Let's go back to that authentication scenario. We're kind of going through that with the users. So authentication has a certain set of dialogues you always have to create when you're doing authentication. You're going to have a login dialog. You're going to have a reset password dialog or a recover password dialog. You're going to really need both of those, because you're going to say, I want to recover my password, and then you're probably going to get an email, and you're going to click on it, and then you're going to get the reset password dialog. And then what if you want to change your password? Or if you're already authenticated, you can just change it if you feel like it, you know? And what if your account gets locked out and you want to enable self-service account recovery? Like, let's say the user puts in their phone number and their email, and so you make sure when you recover their account, say some hacker sent a dictionary attack against their account, and after 25 login attempts in the first minute, you shut their account down, and they come up the next day and say, oh, wow, my account's, wonder what happened to my account. I didn't even try to log in. So to recover the account, you send them a text and an email, and they have to enter both of those values in, and then you say, hey, I know it's you because you got your phone and you got your email. And if somebody else has both of those, then you're hurting bad. I'm still going to give you your account back. So you can do self-service account recovery. You're going to have user interface and SMS and email and all that. So you can build an extensible UI framework. Let's say you're going to use this for two different customers. One's customer one that has a red brand, and another one's customer two that has a blue brand. Well, if you build some basic core functionality and stick it in an assembly that's MVC, and all you have to do is layer on top the red or the blue, then you've got like a whole lot of your work done. Let's say you've got some SMS providers back there to do notification. You've got your token service back there to do authentication and so on. You know, all you have to do to set up a whole robust beast of an authentication system is to put your red and your blue on there. That's pretty cool. So your authentication scenario is going to be some kind of logic diagram like that. Hey, they're going to log in, and then you're going to check to see if their password's expired and so on. And you're going to implement that in this collection of types. You're going to do registration. Hey, how do you register? How do you activate? How do you authenticate? How do you cover your password, change your password, all those things we talked about. So you're going to put that in your extensible user management framework. So then what do we have after we've done extensibility on the token service, extensibility on claims, extensibility on authorization? We'll talk about that in a second. So first of all, you got your UI component pretty much built for all your apps. Then you got your token service. So what's it going to do? Somebody's going to authenticate. Once they get past Authentication Manager, when they get up to there, you're going to send that to the provider that goes against Oracle Access Manager in this case. So it's going to say, hey, those credentials good? Yep, they're good. Okay. Well, now I got to get their claims. So where am I going to get those? Oh, well, guess what? You got claims acquisition providers for that. So you're going to go get those claims. You're going to get a collection of key value pairs as your claims. So then you got to roll that into a token. And we're missing an arrow. Fail. So anyway, you're going to pass that information into your token manager, and it's going to use a provider to create your token. All right. Now, I'm not talking about rolling your own token creator. You're going to use something that Microsoft builds or something that someone else has built, some library. You're just going to wrap it. So now you've got a OAuth token provider or a SAML token provider or whatever you want to use. And then you're going to send that token back, and that's what you're going to leverage in your app. That token's going to be put in your extensible state service. So every time a request comes in, you're going to pull the token out from the cookie, and you're going to be able to know who that user is. And once you know who the user is, now you can tell what they're going to do. Now let's talk about how you could build this. You've got an authorization manager, and you've got rule providers. What's a rule? A rule says there's a thing that I'm going to authorize, and it's called view invoice. All right? So that every app has its own list of rules, and all you have to do is make a set of strings for those view invoice. So when your code comes up to the view invoice rule, you're going to use a user-defined expression to identify if their claim set includes the permission to view the invoice. So you've already built your authorization piece with just some UDEs that are defined. And then the UDE manager is going to have access to all the user context so it can understand that, hey, this is Joe, and he's got these claims, and I'm looking for the invoice claim, and I want to make sure the invoice claim is greater than 10,000, or et cetera, or whatever it is, or I want to make sure it's 2 for view, maybe it's 3 for edit also. So you're going to process the claim value, you're going to send back an authorization on whether that's good or not. And as part of this authentication layer, you can have a notification window service that has SMS providers and SMTP providers and a template manager so you know what to send out, because you got your red ones to send out to your red customer and your blue ones to send out to your blue customer. And all that's driven by extensibility. You can build all of that before you even know what customer you've got, because whatever customer you have, they're going to have some kind of notification that they're going to need. It's probably going to be SMS and email. They're going to have some kind of email template and SMS template for each message. So if you build it out to where your notification service can handle that, then it doesn't matter what customer you have. So that's really powerful stuff. If you build an authentication beast like that, then you have one badass piece of code to lay down when it's time to build a new application or system. Now, one thing I want to tell you about the things to come, the great gap, the hole that we have in our extensibility world today is when you get to your browser and all you've got is JavaScript there. It's just a dog. There's no typing, there's no classes, it's just a dog. And so what we need is something that enables us to do extensibility at the browser level when you're running code inside the browser. So right now we have nothing.
No. There's Blazor.
That's exactly right. We're going to get to Blazor on the next screen. Good job, man. So what we really have is Silverlight. That's what we wanted, right? That would have been awesome, but too bad. So now we have this thing that's running through the W3C right now called WebAssembly. Now I don't know if it's really going to get to a great extensibility tool, but chances are it probably will. I'm going to bet on it. If I have $100 and I want to bet it on whether WebAssembly is going to work for extensibility or not, I'm definitely betting it on the yes. So WebAssembly is a new portable component thing that will run inside your browser, and it's language independent. So it's basically like sending a little .NET assembly to the browser, all right? And you're, hey, guess what? Wasn't that what Silverlight was? Anyway, it's going through the W3C right now. I don't know, maybe the Silverlight team are the ones that really authored this node and sent it to the W3C. You know? Yeah, they probably did. They're like, we're going to win this thing yet. So how can you use this right now? Well, it's very preliminary, all right? But you can get it in Visual Studio 2017 if you've got version 3 or more, all right? This appears to be headed in a direction of like packaging web applications as static runnable files. You could even have your .NET WebAssembly downloaded or served up from a Unix Tomcat web server. That would be pretty cool, right? If you want to try to oh, by the way, it might make it unnecessary for us to use IIS for web applications.
Is this an invitation for new viruses too?
It could be awful.
I mean,
There will have to be a security component here.
it's somewhere. What could go wrong?
Write your C# that reformats the hard drive and send it down to the browser. So you can check it out, Blazor. Thank you, Blazor. There it is. That's what it's called in Visual Studio. And it's play for now, but it might become a really cool thing later. I'm expecting great things from this. If we get it, it fills the gap that we have right now, because that's what we've got. We've got JavaScript hell and so on, and this will help to fill the gap. All right. So that's it.
First, that's one of the things that's one of the issues that we had with the extensibility of Microsoft Office, is all the people put viruses in these files they should get.
Well, think about this.
Who's the idiot who opened it?
Pardon?
Who's the idiot that opened it? Yeah.
But before that.
Anytime you're consuming some code that came from somewhere else and not you, there's always a chance that it has some bad stuff in there, even if it's just script. What's one of the greatest vulnerabilities that ever hit our world? SQL injection. All you do is type some stuff in a text box and it brings down a database, you know? So even
And it's still one of the
It
most common
still is.
vulnerabilities, and there's no bloody excuse for it.
there really is no excuse for it, not on the Microsoft stack.
Not on any stack.
There may be some databases that don't allow you to parameterize things.
Then don't use those databases.
Well, I agree with that. Don't use
John,
those
don't fall for
databases.
using a database that's like designed, hasn't moved past the
Use a
70s.
better database or deal with it. Any questions you guys have?
When you're going through and you have your multiple providers, like you said, either email or you page, what would your method of qualifying a provider be? How would you go about or suggest going to something like that?
Not qualifying it as in deciding if it meets a certain quality standard?
No, as in, for example, is the severity of an action
okay.
go to?
Okay, so in right now, our instrumentation the development effort we have right now in our instrumentation layer attempts to solve that problem in one way. So let's talk about that, and then I'll talk about another way that we can do it. So a cool way to do it, which is what we're working on right now, is the instrumentation schema allows providers to register for events with metadata. So the pager, so not in the config file, which you can't change without bringing the app down, but in the database, so you can change it. So one day your PagerDuty provider doesn't care about this event, the next day it does, because you just change its configure, the events it subscribes to. So it's kind of a subscription, database-driven, defined subscription model. So that way, every provider can say what events they want to handle. But if you don't have that, then you can still, each provider can have its own configuration section or its own code where the PagerDuty, you have a certain set of events that they need to be defined in a database. And then your PagerDuty provider needs to be able to say, hey, these types of events I want to handle. And so somewhere you're going to have to define it in metadata unless you want to hard code it, which you don't want to do. So somewhere you're going to have to define it in metadata. Config file, database, somewhere that links up the provider with the things it wants to handle. So however you create your model, I mean, you can create it so that every time you fire an event, it has like some metadata with the event, like what's the type of the event, what's the category, basically what's the type of the event. What type of event am I firing right here? Here's my message, or here's my info, maybe some rich information to go along with this type, and then each provider can key on the type and say, every time a type of this comes along, I'm interested, but if it's type of this, I'm not interested. So does that answer your question? Okay. That's how we're doing it. We're defining the metadata in the database. So that when you set up the app, you say, okay, what are our instrumentation providers? Okay, there are these four. Okay, what are our events? Well, our platform has a certain set of events that are there, like login is an event. We're always going to ship an app with a login event. But then each app has its own problem domain, and you have some other events that you want to add that are problem domain dependent. Like this app is about cars. So every time somebody wants a blue car, I'm going to fire the blue car event because there's the blue car manager that wants to know that. As soon as that happens, he wants to pick up the phone and say, hey, I've got some blue cars. So each time you build an app, you have your app events and you have your platform events. Your platform events are kind of default. Your app events go on top of it. And then your providers select a subset of those and say, okay, these are the ones I want to handle. So when your provider is sitting there, you can either have the manager do that logic and figure out that, oh, this event is only going to be subscribed to by these two providers, so they're the only ones that I'm going to engage. Or you can have the manager just throw the event to everybody and each provider decides for itself. That takes a little more time. That's not as performant, but it's also easier to code it that way. Question?
Are you aware of any efforts along the lines of these principles being applied to the IoT space? Because I guess as I've examined IoT types of things, one of the common themes that I see is surrounding security.
So I would say that anybody that's going to create great IoT technology is going to create extensible IoT technology.
Kind of inherently has to be.
Great technology is extensible. If you create something that's not extensible, it's never going to be great. I don't care what it is. Maybe there's some crazy exception to that. But if you're going to be ubiquitous, if everybody's going to use you, if you're going to get a certain market share, if you're going to get 20% of the business, you're going to be extensible because everybody's going to want to do it a little bit differently. Everybody's going to need something differently. So if you're an IoT component and there's a security concern, well, you need to be provider driven around that so that I can plug in one security component today and then another one tomorrow because it's got, this one doesn't handle the threat I want to handle. So all of it has got to be extensible. If you're building software for one customer and only that one customer, then you don't have to build a single line of extensibility into it. But if you're a software builder then keep making your tool set better by building more and more extensible things in it. So even if you do have to build something for that one customer that's only going to be theirs, you have to spend less time on it because you've already got some extensible stuff that you're going to throw down. All you have to do is add your providers on top. Chances are you've already got them, some of them, and then all you have to focus on is the problem domain logic at hand. And even that can be helpful. You've got extensibility things that are already built in, like when it gets to validation of user, attributes, all you have to do is write an expression instead of coding it all out. You've got a framework for it. So I say yes, great. Anything that's going on right now in the IoT space that's going to be great, whoever's doing it is thinking about extensibility, and they're building it in.
All this changing providers and everything, is the option to do it while the app, without bringing the app down?
So that's a great point. So another thing that we have in our platform is we don't do much configuration in the .NET config file. I mean, you see it here in these samples, but we put it in a database. And we have timers. So you can change your configuration, and the timer, when the timer runs and goes and checks to see if your configuration has changed, it's going to realize it has, and then it's going to do what's necessary to invoke that new correction and change the behavior at runtime. You got to be careful about that because your website that supports your $30 billion business, some developer could change a configuration and bring it down. But the beautiful thing about it is that as a developer, as an app controller, you can basically set up your governance so that these people can change the configuration of the production apps when it's needed. You can turn logging on or off. You can change your database because this one's down and the DBA says I can't get it back up for 45 minutes, so you're going over here, so you're only down for 5 minutes. So all those things you can do. It's nice if you can build timers in. What you have to do in your manager classes is the manager class, threads running in the manager class, there's a new config, okay, it processes it, sets up the new provider and gets everything ready to switch. Then it blocks every call that's coming to the class. So that means every method has to have a lock in it. So you all of a sudden lock everything. Actually, every method is locking, so it's going to slow it down to do it this way. You're going to have some synchronization built in. But you lock the component that everything is sensitive on, and once you lock the component, no threads are going to get into the manager class. So right then, you switch the providers out and unlock it. You don't lock it and then process the configuration. That's slow. You process the configuration, get everything ready to switch. Lock, switch, unlock. And so that's really cool. I really like that coolness. And
Hot swapping.
yeah, hot swapping configurations. It's good.
Well, and the important part too, and this is a general rule for locking, right? Keep your lock as narrow and as slim as possible.
Right.
Because, I mean, I've seen this happen, right, where folks will lock these large blocks, 75–80% of the code in there doesn't need to be in a lock, right?
Right.
And you wind up spending 3 or 4 or 5 more times inside of a lock that can have some pretty expensive implications across the entire application than you absolutely need to.
Yep, so lock skinny. And I do like some things you really can't change very effectively on the fly, so may not enable those for that, but most things you can, and certainly a lot of things you can. And I can tell you so many, and I only know a tiny little number of them. I mean, there's so many millions of stories out there where bad things have happened in larger enterprises and no one's been able to do anything about it because the process is so thick to change something on the production servers and get a change request to happen. And if you use .NET config files, then you have to put a new config file down on the production server to get the change done. And usually that's a beast of a process. You've got a lot of approvals. I mean, if you got a website that's making you 20 million, 5 billion or more a year, you can have a beast of a thick process that is going to have to happen before anybody's going to be able to touch that file. And then after they touch the server, you're going to have a whole host of tests to run. It's going to take probably hours to get all that done. And so it's really nice if you can have some governance, some organization approved governance around config change management that makes that simple and easy and short circuits the process. I mean, you can't cheat the process. You can't say, oh, well, our process is so thick, I'm going to let developers change the production databases. I mean, you can't do that, because then you're going to get into trouble, with people making mistakes. But you can use dynamic configuration to shrink the amount of time that it takes to execute the right process, which is all goodness. And that's going to bring extra grocery money when it comes to bonus time too. Because everybody's going to say, wow, your app is up all the time, but mine's not. So I guess that's why you got the extra grocery money. Anything else?
Is your code available online? All the stuff that you showed?
Some of it is. I'll package some of it up and give it to Jay so he can look at it.
Most systems.
Yeah, so you can look at it and host it, and maybe. No, I don't think you should charge anybody for it.
That's a good idea.
Do you have
It
any
is.
insight on the Fulcher project? Do you know is that going to be a viable?
Well, all I can say is Silverlight was the Uber web technology until the evil Axis powers got together and decided to go down HTML5 path. I mean, all these standards for web, all they make you do is take the lowest common denominator approach. So HTML5, all the HTML5 apps that I've ever seen are disaster. None of them are HTML5. Anyway, Silverlight was great. So if that can just get through the standards body, then all the vendors are going to have a new battle to fight, a new battlefield to go to war on.
So it's still in process.
And the power of the .NET language set and the CLR is going to have, that's going to be a beast of a cannon to use on that battlefield. Yeah, I don't know anybody that's going to be able to compete with that.
So it's still alive, being chewed on?
The WebAssembly thing?
No, Silverlight.
No, Silverlight's dead forever, but it's going to, okay, so let's think of a good analogy. Silverlight is dead, but Silverlight is going to be rebirthed as WebAssembly. It's just going to look different. It's going to be called something different, And just wait. So there's going to be WebAssembly. Then Microsoft's going to get together and build this beast WebAssembly that's going to be like amazing. And everybody else is going to compete to do that too. And all the browsers are going to run the code. Wouldn't it be nice if Chrome would run C# code? That's what's going to happen. Chrome's going to be running C# code. Now, if I was Google, I probably wouldn't like the WebAssembly project. I probably want to make that thing last a long time before it got to be a recommendation at the W3C.
They're a bunch of Python guys, aren't they?
Yeah, they're not going to be able to compete with the kind of WebAssembly technology that can be.
You got a ways to go before those download packages are still pretty in the mix.
It's going to take a while. HTML5 started a few years ago, and it's going to last 30 more years before it's all, implemented in all the browsers. I mean, some pieces of it are still getting whacked, and some pieces of it are never going to be implemented. But this WebAssembly thing, there's security concerns, but if I can just package a thing that the browser can run and all the browsers will support it, then I've got like nirvana right there. It's just a matter of time before I'm going to be able to put some really fantastic MVC-ness in that and do some really cool, client-side stuff. I'm going to have WPF on the browser. Oh, wait, wasn't that what Silverlight was? Anyway. Anything else you guys want to talk about?
42.
42.
What is 9 times 6?
That's the answer to everything. Thank you very much.
What is 7 times 6? 9 times 6 is 54.
That's
No,
right.
9 times 6
His record
is
there, you got
42.
Yes.
Yeah,
Is
that's
it?
Nate's 13.
Oh, all right, awesome. I love that. Yeah. 42.
The question of is 60%.
Yeah. Perfect. Thanks, guys.
Thank you for joining us for the March 2018 meeting of the Houston.net Users Group. Our next meeting will be on April 12th at the Improving Houston office at 10111 Richmond Avenue. If you happen to be in Houston then, or on any second Thursday, we'd love for you to join us.